Greetings of the day, dear students. In this video, we will discuss about the common emitter, common collector amplifier. We will see its circuit diagram. What is the basic circuit diagram we are having for its operation, and also where the input will be given and where used to collect the output. If it is CE amplifier, common emitter amplifier, right? And what could be its circuit operation, right? And also we will discuss the common collector amplifier, right, where we used to give the input and where we have to take the output. Those parameters are important. It's a circuit diagram, the directions of current, the polarities of the voltages, right, where the input is to be given and where the output is to be taken. Those are to be highlighted. And also we will discuss the circuit operation in this video, right? We are going to discuss the common emitter amplifier and common collector amplifier, right? Dear students, if you observe with respect to the common emitter amplifier, the emitter will be common. This is the emitter terminal. Emitter will be common to both the input and output. So how do you understand that? The input will be given across the base emitter and the output will be collected across the collector and emitter. That is the CE common emitter configuration, as we have discussed in our previous basics. Now in this CE amplifier, if you consider a NPN transistor, obviously indicate these points. If it is a common emitter amplifier, NPN transistor, now this emitter will be of N type, emitter will be N type, and the base will be P type, and again this collector will be of, now this collector will be again N type. So NPN transistor we have considered. If you observe VBE in this diagram, VBE indicates the voltage across the base and emitter, right? IB, this current IB indicates the base current. IC indicates the collector current. VCC is the collector terminal voltage. IE is the emitter current. So dear students, while attempting this question in an exam, it is important to draw the circuit diagram and also highlight the variables. What are all the variables present in this diagram, so that you can get the more marks. You can get more marks and by indicating all the variables, right? So IC is the collector current, IB is the base current, IE is the emitter current. Now RC is the resistor connected to the collector terminal, RB is the resistor connected to the base terminal, and VBB is the base terminal voltage with respect to the ground. VBB is the base terminal voltage with respect to the ground. Now as all capacitors connected for filtering purpose, C1, right? And also you are having VCC we have discussed already, right? Yeah. Now input signal is injected to the base emitter circuit. This is very important. Where the input is given, dear students, the input is given across the base emitter and the output is taken from the collector emitter circuit. This is very important. Now the emitter base junction is already forward biased, right? With the help of this VBB base voltage, this junction is forward biased, and the collector base junction is reverse biased with the help of VCC. Now the operating point or working condition is determined by what? Is determined by VCC. Now in this diagram also you can observe IC is the collector current, IB is the base current, IE is the emitter current, VB is the base emitter voltage, and VCE is the collector emitter voltage. Now this is the input given, right? This is the sinusoidal input given. For the given positive peak input, you used to get the negative peak output. So for positive signal you are getting the negative signal as an output if it is common emitter configuration, right? This is we can observe here. Here you are given the positive peak, you got the negative peak, negative as an output, right? Now what could be the operation? As we have told you that already the base and emitter is increased. Already it is positive with respect to what? Ground. Now already it is forward bias. Once the base emitter voltage is increased further, it leads to the more amount of base current to flow. IB will be increased. IB is increased, right? As and when VBE is increased, it leads to the increase in the forward bias of the emitter base junction. Very, very important. If you are increasing the VBE voltage, so the forward bias voltage of base emitter junction is also getting increased. Because of that, the IB current also increases. Current flowing through the base will also increase. Now we have the relationship between the collector current and base current. Once IB is increased, the collector current, if IB base current is increasing, right, IC will also increase by beta times. The collector current also will increase by beta times. This is the sequence of operation, right? The base current has forward bias voltage is increased. Because of that, base current is increased. Because of that, collector current has increased. Now once the collector current has increased, IC/RC in our electrical point of view, V equal to IR, the voltage drop IC/RC will also get increased. Because IC has increased, so IC/RC also will increase. So IC/RC is increased, and now if you observe, VCC is given by VCE plus IC/RC. VCE plus IC/RC. What amount? The amount of current flowing through this collector resistor. IC/RC amount of voltage will be wasted, right? Therefore, the voltage across the collector terminal VCC will be equal to this collector emitter voltage plus drop. Voltage across collector emitter plus drop. Now what could be the collector emitter voltage? Collector emitter voltage across collector and emitter VCE will be VCC minus IC/RC. VCC minus IC/RC, right? So this is the voltage equation we can observe. This is how the voltage, this is how the common emitter amplifier works, right? Now the negative half cycle of the output is obtained, as I have told you earlier. For the positive peak, you used to get the negative output, right? And the positive going input signal becomes a negative going output signal, right? Yeah. So this is what all about the common emitter configuration. Dear students, simply to say, emitter will be common to both the input and output. Base emitter will be forward biased. Collector emitter will be reverse biased. Base emitter forward bias voltage, if it is increased, base current will increase. If base current increases, the collector current also increases. If the collector current increases, the drop across RC will also increase. And finally, the collector emitter VCE voltage will be given by VCC minus IC/RC. VCC minus IC/RC. For the positive given peak, you will get the negative peak as an output, right? So this is what all about the common emitter amplifier. Now, dear students, let me discuss about the common collector amplifier. As I discussed earlier, in CE amplifier, emitter will be common to the input and output. In common collector amplifier, the collector will be common. In CC configuration, as we discussed earlier, collector will be common to both the input and output. Now here, this IE indicates the emitter current, IC indicates the collector current, IB indicates the base current. RB is the resistor connected to the base terminal, right? RE is the resistor connected to the emitter terminal. VCC is the voltage across the collector terminal with respect to the ground, right? Now if you observe, this is the given input voltage, and this is the obtained output voltage. How we will obtain the, how will be the operation? Let me discuss the operation. When positive half cycle is applied, dear students, as and when this input is having a positive half cycle and also a negative half cycle, right? When positive half cycle is applied, then across the base and emitter, the forward bias is increased. The forward bias is increased. Now, since base emitter voltage VBE is positive with respect to the collector, that is ground, right? And it leads to the increase in the base current. It leads to the increase in the base current. Once the base current has increased, the emitter current also will get increased. In the previous case, common emitter amplifier configuration, if base current has increased, correspondingly the collector current also has increased. In CC amplifier, with the increase in the base current, you can observe emitter current is increased. Now once emitter current increases, right, because the current is also flowing through the emitter resistor, IE V equals to IR. From this basic, IE drop also will increase. The voltage drop across emitter resistor will also increase, right? So because of this, what will happen? The output voltage will be increased. Consequently, you will get a positive half cycle as the output. But in the previous common emitter amplifier, for a given positive peak, we got a negative peak as an output. But here, in common collector configuration, for a positive peak, we used to get positive peak only as an output, right? It means the positive going input signal will result in a positive going output signal, right? Now the input and output signals are in phase with each other. Both the signals, both the waveforms will be in phase with each other. This is how the circuit operation. So dear students, with respect to the common collector amplifier, the important point is where you are giving the input and where you are obtaining the output, right? Now once it is forward bias, the base current is increased, correspondingly the emitter current is also increased. Because of that, the drop across IE, the drop across RE also has increased. Now the output voltage is increased. So these are the points to be highlighted while attempting this question in an exam. These points, the circuit diagram, waveforms, variable names, if you highlight these points, easily you will get good marks. It is very easy to pass, right? So don't forget to highlight the key points. So dear students, this is what all about the common emitter and common collector amplifier, right? Of course, in this amplifier things, we have not gone in depth into the derivations. So many derivations can also be done, but just simple basics are enough, right? He won't ask the derivations to do all the derivations. For example, if you are interested, we can calculate its output voltage. We can calculate the gain, output voltage by input voltage, right? If it is common collector amplifier, we will get a value of 1. We will get a value of 1. And also we can go in depth into the what could be the biasing voltage, current, what could be the emitter current, emitter resistance, AC voltage gain. All these things can also be discussed. But for your exam point of view, he won't ask you the derivations. Just he will ask you the circuit diagram, its operation, and what are the waveforms we are obtaining, right? Otherwise, we can highlight all these points, how the voltage, output voltage can be expressed in terms of VCC, collector terminal voltage into voltage dividing rule. This circuit can also be considered. This is also one more other configuration for common collector amplifier, right? Using a NPN transistor. This is how we can attempt this question. right? All these derivations part we have not discussed. Okay, thank you.